So far we've looked at ways to solve algebraically. Now we're going to talk about how you solve these equations graphically, solving the system graphically. In order to solve it graphically, what you're going to do is you're going to graph both the lines and you're going to look for the intersection of 2 points. You're going to look for the intersection of 2 points. One of three things can happen. Either the lines will intersect at a 1 point. They're going to intersect at 1 point. If they intersect at 1 point, we call that a consistent and independent solution set, or system in this case. If they intersect, if you draw the line and you draw the exact same line twice, that means they're the same lines. We call that the solution set is infinitely many solutions, and we call that a consistent and dependent set. If you draw the two lines and the lines never intersect, those are parallel lines, we call that an inconsistent system. So when we solve this then, again, we're looking for the intersection. So if you look here, this again, if they intersect, this is called consistent and independent. If they don't intersect, this is called if they the exact same line, this is called consistent and dependent. And if they don't intersect at all, they're parallel lines, this is called inconsistent. So when we do this, let's go ahead and graph this first equation. In order to graph, we need to get into y equals form. So the first equation, 3y equals 2x minus 6, when I do that, if I want to graph that to y equals form, in y equals form, that'll be equal to, divide everything by 3, so I get y equals 2/3 x minus 2. Plotting that line, my intercept is -2. My slope says go up 2 over 3. Up 2 over 3. Up 2 over 3. One, two, 1, 2, 3. 1, 2, 1, 2, 3. There. My other equation, get y by itself. So I'm going to move the x over, so I get y equals -x plus 8. Intercept is at 8. Slope has to go down 1 over 1. Down 1 over 1. Down 1 over 1. So do you see that they are intersecting here at this point? So if I graph those lines, I get here and here. And the solution set here is the point where they intersect at. In this case, that would be the point. The x coordinate is 2. The x coordinate is 6. The y coordinate is 2. So 6, 2 is the solution set here. And this is what we call, because they have one intersection, this is called consistent and independent. Independent because it's unique. It's a unique solution. If we look at the next equation, 2x minus 4y equals -10. Again, I want to get y by itself. So to get y by itself, I'm going to subtract off first. I'm going to subtract off the 2x. So I get -4y is equal to -2x minus 10. Divide everything by -4. So I get y is equal to 1/2 x, right? Minus that'll be a -5 over 2. -5 halves, or 2.5. So the slope here is 2.5. That says 2.5, go up 1 over 2. Up 1 over 2. Up 1 over 2. So I get a line looks something like this. The other one, when I graph that, get y by itself. So that'll be 2y equals x plus 5. Divide by 2. Divide by 2. Here, it looks like y is equal to 1/2 x plus 5 over 2. So the exact same line, by the way. So this is the exact same line that you're graphing. My green line and my red line are the exact same lines. Because they're the exact same lines, they're the exact same equations when you write them out. Exact same equation when you write them out. This should have been a plus 5/2, by the way. I'm sorry. Because of that, this is what we call the answer here is the solution set is written as infinitely many. That means any XY pair on the line will work for this, infinitely many. And we say this is what we call a consistent. You get a solution. Consistent means there is a solution, but it's dependent, which means that the solutions are not unique. So you get a solution, but they're not unique. And then in the last one, let's get these equations by themselves. Get y by itself here first. So to do that, move the x over. I get negative 6y equals a negative 3x minus 9. Divide by negative 6. And I get y is equal to a negative 1/2 x, or a positive 1/2 x, I'm sorry. Because negative divided by negative is a positive. 1/2 x. Negative divided by negative is a 3/2, or 1.5. So the line looks like this is 1.5 here, and it says to go up by 1 over by 1. So up by 1 over by 1. Oh, over by 2, I apologize. Up by 1 over by 2. Up by 1 over by 2. Up by 1 over by 2. So that's the first line. The second line says get y by itself. So 4y is equal to 2x. 2x plus 12. Divide everything by 4. And I get y is equal to 1/2 x plus 3. So 1/2 x plus 3, up 1 over 2, up 1 over 2, up 1 over 2. Notice that these lines have the exact same slopes. So because they have the exact same slopes, what that means is that they will never intersect. My lines aren't perfect. That's why they might intersect. But here they will never intersect. These are parallel lines. By definition, the word parallel means that you have the exact same slope on your lines. And for both these lines, you have 1/2 as your slope. If you ever work the equation and you get the exact same slope, you don't need to graph them. You're going to have parallel lines. The answer here is no solution. They will never intersect. And because it's no solution, there are no solutions. This is what we call an inconsistent system.